The USTA is a digital module that outputs and receives control voltages. This means that it has an analog to digital converter and a digital to analog converter. By default, these are factory calibrated, but you may need to adjust them according to, for example, your case or your new power supply or after a firmware update. This is how we do it. First, we are going to calibrate the CV outputs and then we will move on to the CV inputs. To perform the calibration, we need a precise multimeter. To access the calibration page, hold down the play button and turn on your case. At this point, we suggest to let USTA warm up for 30 minutes. This is the trimming menu, and it contains 32 settings for the 8 CV outputs and 4 settings for the 2 CV inputs. The USTA outputs are based on an octal 16-bit digital to analog converter with 65,536 steps. The lowest and highest voltages that USTA can output without any trimming go from roughly -5.5 volts up to around 10.5 volts, which translates on roughly 16 volts of range and an amplitude difference between each step of around 0.2 millivolts. The CV outputs in this menu here are numbered from 1 to 8 from top to bottom, so this is output number 1, this is output number 2, 3, 4, 5, 6, 7 and 8. You can see that every voltage has 4 values, -5, 0, 5 and 10 volts associated with their internal value. To calibrate the outputs, we are going to change the digital value so that the output matches the label here. Let us start from the -5 volts of input number 1, which is a CVA of track 1. Push the navigation encoder to make USTA output the corresponding value and rotate it to change and trim the value. You can see that as I increase this value here, this number gets close to -5. There. And then we can confirm the option and move on to the 0 volt of the same output. Now, if you cannot achieve a precise number, don't worry. This, for example, is 1/10 of a millivolt. And then we change the output and we move on to the output number 2. And we repeat the procedure for all of the voltage outputs. Once we have successfully calibrated the last voltage output, we can push play to store the new values. Now we can proceed to the input trimming. At this point, we no longer need a multimeter, but instead we need a precise voltage generator capable of generating at least -5.5 volts up to 10.5 volts. If we don't have it, no problem. We can use our finely tuned USTA to generate these voltages. We need to trim 2 voltages only for the inputs, the -5 and the +10 volts. These are the 4 pieces of data that we need to adjust to trim the 2 voltage inputs. For each input, we are going to calibrate the -5 volts and the +10 volts. These 2 numbers that are constantly updating on the bottom of the screen are the values that the ADC is currently reading for inputs A and B. Now we don't have anything patched, so it is reading the 0 volt. What we need to do is to send to these inputs signal corresponding to -5 volts and +10 volts and make sure that this number here matches this one. This number is the DAC value that USTA internally associates with -5 volts. This is the +10, this is the -5 for input B, and this is +10 for input B. As I said before, if we don't have an external generator of -5 and 10 volts, we can patch the output number 1 to the input that we want to trim, and USTA, once we select the corresponding value, will automatically route the desired value. For example, now we need to calibrate the -5 volts on CVA input. We can see that the value is slightly higher, so we need to select the option and rotate until we reach the average value between the one read by the DAC. The numbers are constantly updating due to the DAC's approximation. Then we can move on to the 10 volt. We change the input and we move on to -5 volts for the input number 2. Once we are done, we press play to store the new values. Then we can turn off the USTA and turn it on again. That's it.